Okay, guys, we are on part B, or part 2 of our notes. We're gonna kind of be tying everything together that we've talked about and trying to just make a general analysis of a rational function is where we're at, okay? So first and foremost, we want to make sure that we can factor and simplify, okay? So that's our first thing is everyone say, I can factor. No, we can. Yes, we can. Okay. We're gonna factor first. So we're starting here with our, am I not, is this where we are, right?
Yeah.
Okay.
Yeah.
So we're gonna factor the numerator. We have 3x squared minus 8x minus 3. So to factor the numerator, we've learned skills since algebra 2. It's either by X box or grouping. Okay. And the reason why I have to use one or the other is because my A is greater than 1. When my A is greater than 1, I can't do mental factoring. I can't simply just ask what multiplies to give me my C, but adds to give me my B. I have to do one or the other, right? So if I choose to do grouping, which I personally do grouping because that's what I learned and that's what I stuck with. I did not learn anything about an X box until I became a teacher. So grouping wise, I'm going to have 3x squared, but I'm asking myself what multiplies to give me -9, but adds to give me -8 to replace my -8. So what multiplies to give me -9, but adds to give me -8. -9 and 1. So I have -9x plus 1x minus 3. All I'm doing is substituting in for that -8.
Wait, so repeat that again. So
what multiplies to give me my A times my C. So my A is 3, my C is -3, which is -9, but adds to give me my middle term, which is -8. And that's why we said -1 and +1, -9 and +1. Does -9 plus 1 still make -8? Yes, all I'm doing is substituting that in so that I can now factor by grouping. Does that make sense? I'm just substituting it in. So I factor by grouping, boom, boom, boom. The GCF here is 3x, and I'm left with x minus 3. The GCF here is just 1, and I'm left with x minus 3. My common binomial now is x minus 3. When I take the common binomial out, I'm left with 3x plus 1. That is the factor of my numerator. Yes. I've heard that. I do not know that. If you do it that way, by all means, use that shortcut. Yes, 100%. Whatever the slide and divide. Someone tried to do it to me in a training and I said, stop it. My brain can't hold it.
how do you get to the bottom part?
It works if you understand this, but if you don't understand factoring or GCF, then it doesn't. This part,
Yeah, I get that.
so your next step is you're finding what is the greatest common binomial. So each one has an x minus 3. When I factor that out, remember when we factor something out, it doesn't go away. It's just been kicked out, right? So I factor it out and I'm left with 3x plus 1, and that's my third factor.
And the x minus 3 is what you factor.
Exactly. Okay. So now my numerator is x minus 3 and 3x plus 1. My denominator is basic factoring, right? It's difference of 2 squares. Difference of 2 squares means I take the square root of the first term, the square root of second term, and I add and subtract those, correct? There we go. So we end up with x plus 3 and x minus 3. Difference of 2 squares is one of our favorite mental factoring shortcuts. Did we fully factor? Yes. Now we're going to simplify. Simplify means to eliminate a common factor, if possible. Is there a common factor?
Yeah.
What is my common factor? X minus 3 is my common factor. Okay. So now we've done everything. So what we're left with here is 3x plus 1 over x plus 3. And because I eliminated, what does that mean? There's a hole. So this is a function with a hole at x equals 3. Agree? Because that's what I eliminated, correct? if you can eliminate, there's a hole in my function, I'm pulling something out. So I can eliminate the factor of x minus 3. So at x equals 3, there's a hole there. Okay, so when you look at your graph, does that make sense? Why at 3, there's a hole? Yes? All right, so the coordinates of the hole. So how do you find the coordinates of the hole? Well, you know your x value. So to find your y value, you're going to plug it into the simplified function. So we're looking for f of 3. So when we plug this in, we get 3 times 3 plus 1 over 3 plus 3. 9 plus 1 is 10. 3 plus 3 is 6.
Oh, you're supposed to do that. Oh, never mind.
So my hole is located at 10 over 6, which reduces to what? 5 over 3, 5/3, like 1 and 2/3, right? So it's at 1 and 2/3. Does that make sense when I look here and it's at 1 and 2/3? 10 over 6 becomes 5/3.
Yeah.
Right?
Yeah.
So my ordered pair, my hole is at 3, 1 and 2/3. Hence, right here, this actual value is 3 and
1.66666.
we're gonna put a repeating, right? It just goes on and on and on. Okay. Do we need to close that? Can you close it? All right. How do you feel? Let's go over our checkpoints of what you should be able to do. Do you feel confident factoring?
Yes, I do.
Yes. Do you feel confident simplifying and identifying a hole? So right here, this part, we eliminate it, and this is simplified, and we identified that there's a hole. Yes.
What if you're doing the grouping and you get to like that first step you have where you have the 2 sets in parentheses but they're not, like it doesn't.
Well, that means that either 1, you made a mistake, or 2, what you're dealing with has a complex 0. Yeah, that's what it means. And then you would have to do the quadratic formula.
Like part 2 worksheet goes like that. Yeah. Kind of give up there.
Did you use quadratic formula?
Okay.
When grouping fails, remember quadratic formula is your catch-all. When grouping fails, yeah, if grouping fails, if you cannot do any type of factoring, you must do quadratic formula.
I forgot.
Yep, you must do quadratic formula. Okay, all right, so now our domain. Our domain is based off of our restrictions in our graph. So we're gonna identify restrictions by saying our asymptote, same for our range. So first, we're gonna state what our asymptotes are. We already know we have a hole, but now we gotta state our asymptote, okay? Where is our vertical asymptote in this graph?
Negative.
At x equals -3, right? It's a vertical, so it's at x equals -3. I can look at it graphically and see it, and I also know it because if I plug -3 in the denominator, what is it going to equal? 0, and is that allowed? No. Okay. All right, our horizontal asymptote. Our horizontal asymptote depends on, we talked about this yesterday, the degree of our numerator and the degree of our denominator, correct?
Yeah.
The degree of our numerator and the degree of our denominator are the same, yes? So all we're looking at is their leading coefficients. My leading coefficients are 3 and 1. So my horizontal asymptote is at y equals 3 over 1, which is just 3. And this is going to be y equals 3. I have now identified all of my discontinuities. So therefore, I can now write out my domain and my range. Yes? All right, so my domain. Coming from left to right, I'm doing fine. So we start at -infinity. We're traveling along, and oh no, there's a pause in my graph. That is my vertical asymptote, right? Then we get back on the train and we're traveling along. And what happens? We're traveling and then, oh no, there's a hole in my graph and I have to stop. Where's that hole at?
3 and 1.
3 is only the domain, so we only look at the X. And then we get back over that hole and we keep going.
It'll be 3 and, positive.
3 and positive infinity. That's my domain. And that's my domain because X cannot equal -3 and X cannot equal 3. Stop. Stop. Keep going. Yep. All right, now we're gonna do the range. Your range is from bottom to top. So starting from the very bottom, we're all the way down at negative infinity. We're traveling along, and you're like, oh, there's a hole in my graph. And where's that hole at? It's at 5/3, right? 1 and 2/3
1.6.
or 5/3. It's just easier to write 5/3, guys. Fractions are our friends. Okay. I stop and I get back on and I'm traveling along like, oh no, there's a stop in my function. Where am I stopping at? I stopped at 5/3 and I get back on and now I'm stuck at 3. Then I get back on the other side and what happens?
3 and
And I keep going 3 to infinity.
okay.
Okay. Again, domain is left to right. Range is bottom to top. And these are telling us where our stops are. Where are we stopping? We know that X cannot equal -3 and +3. And on this end, we know that Y cannot equal 5/3 and Y can't equal 3. That's why we are having to stop. Does that make sense? Yes? No? Maybe so? We're good? All right. We're going to keep analyzing this. Now we're going to talk about, once you've identified this, we're going to read our limits. The thing is explaining our limits. Yesterday, we talked about how to read what the limit is saying, right? So this is saying limit as X goes to negative infinity. So as X goes to negative infinity, is I'm asking what's happening to my function as it goes forever to the left. Make sense? So what's happening to our function as it goes forever to the left? It's decreasing, but what is it trying to approach? 3 is trying to approach this asymptote, right? We're not going to negative infinity. We'll never go all the way down. We're trying to approach this 3, the asymptote. Okay, this is saying the limit as X goes to positive infinity. So we're asking as it goes forever to the right, what is your function doing? As it goes forever to the right, what is it trying to approach? 3. Is it going to actually ever touch it?
No.
No, but it's good to have goals. Okay.
Okay.
It's a +3, or asymptote. All right, now this is describing our asymptote behavior. So as our function is going towards our asymptote, so as I'm going to the asymptote on the left, what is it doing? So this is asymptote, because that's where -3 is, our asymptote. As I'm heading left to my asymptote, what are my Y values doing? They're increasing and they're heading towards what? Infinity, positive infinity. Okay,
Look at it at right
yes.
at the bottom of the graph.
I'm -3 is the vertical line.
Okay, yeah.
So as we're coming from the left, what are my Y's doing?
I was going up.
Is going up, is heading towards infinity, right? Now, when we look at our graph around our asymptote, because -3 is where our vertical asymptote is, right? As I come from the right, what is it doing?
Going down.
So if I'm going down forever, then I'm heading towards negative infinity. Okay, now we're going to analyze what's happening around the hole in our function. So coming from the left of our hole, what is it approaching? If we could, what would it touch? What did we say that value was?
3.
No, what is the Y value? Your f of X. What are you approaching? You're 5/3, right? You're 1.666666, yes,
6, 6, 6, 7.
I didn't know that you're doing that.
because it says X is 3 and 3 is where our whole is. And it says here, X is -3 and -3 is where our asymptote is. So pay attention to the value that it's having you look at. Okay, good question. And so this one is heading towards 5/3. Coming from the right, heading towards our whole. What is my goal? What do I want to touch? My goal, my Y value, what is here at the whole? 5/3. Okay. A limit is your goal, right? Your limit is your goal. Do you always achieve your goal? No, you don't, sadly. That's why it's what are you constantly striving for, right? So in this case, we're constantly striving to get to 3, or we're constantly striving to get to 5/3. Yes, no, maybe so? Okay. All right. Questions about example 5? That's what that little, your superscript is.
The negative makes a lot of sense.
Exactly. Perfect. So if your superscript is a negative, that means you're heading to the left of it. If your superscript is a positive, that means you're heading towards the right of it.
But like for the whole one, as X comes from the left, wouldn't it hit -3 before you mix the 3?
No, because we already know that it's breaking. So as I'm coming from the left, I'm now already acknowledged this asymptote, right? So now I'm here saying, okay, as you're coming from the left of the whole, not the left of the whole function. Does that make sense? This is saying the left of the whole function. This is saying the right of the whole
So
function.
why is it not -3? The left of the whole function?
The left of the whole,
That.
because this is what's directly left of the whole. So like
No, but as X goes to negative infinity, why is it not -3?
as X goes to negative, oh, I didn't write my negative.
Okay, I was really confused. Okay.
No, I'm right. You're looking at your Y. You're looking at the Y. This is your positive. This is it. This is the Y that you're heading towards. It says f of X. F of X means what is your Y doing? My Y's are getting closer and closer to 3. They're never gonna reach 3. So as my X values are getting smaller and smaller and smaller, they're gonna keep trying to get closer and closer to 3. And that's what your limit is saying. What are your Y's trying to get to?
So
What is your Y? What is your goal?
What about the vertical aspect of -3? Like, what's that?
This one?
Is that what that is?
This is describing your asymptote behavior.
How do you know, like, do you just have to memorize like, how do you know which curve to look at? Because like, you could look at that one for. Yeah. That's what I was looking at.
This one right here?
Yeah, I was looking at.
So you're looking at your limit as X goes towards negative infinity. My X's stop right here. My X's can't pass -3.
Yeah.
Right? On the right-hand side, my X's cannot go past -3. So if I'm looking for forever going to negative infinity, I have to use this one because it's the only way that my X's can keep going to negative infinity and describe that behavior. Does that make sense? This one, if I'm just saying, well, this is it. This is describing your asymptote behavior, which is why here on this one, our limit as we're coming from the right of our asymptote. So this is our asymptote and this is the right of it. The function is going down forever, right? It's going to keep getting smaller and smaller and smaller, but it'll never actually, I can't go past that asymptote. Okay. All right. Good questions. Love them. All right. But we're good there. Okay. All right. So number 6.